Hi Year 10, this is Connor here again. If you could just rule off where you got to last lesson before half term. I hope you had a good half term break actually. Well, it was good, wasn't it? But if you could just write the date and the title, underline them, then have a go at this first do now. That should say recap. Let's have a look here. So here, look. There we go, that's better. How good is this, by the way? So if you just write the title and the date, underline them, and then have a go at this first do now recap. We're going to do 2 today. It'll take a little bit longer, that's not a problem. Have a go at the first 2 do now tasks here, and please pause the video as you do this. Right, good, brilliant. Quickly fly through the answers. So you should have 16 and 19, because you're adding 3 each time. 16 and 11, subtracting 5 each time. Then we've got 36 and 49 and 21 and 28. It says here you've seen and used these sequences in a previous lesson. What is the special name? Well, I'm hoping you've remembered that these are our square numbers. Okay, and then these ones here are our triangular numbers. Okay, so you might want to label those alongside the sequences. They're really, really important as we go through this chapter. Then we're looking for the nth term rule. So remember, the first thing that you had to do was just to find that common difference. So what you're doing each time, well, you're adding 2 each time, and that happens between every term. So it's 2n, but then we know that if we're starting n as 1 here, 2 times 1 is 2, we want 5, so we have to add our 3. Next one here, so we get a common difference of 4, so it's 4n. 4 times 1 is 4, but we don't want 4, we want this 3 here. That's why we subtract 1. And then we're going downwards here, so remember your n value can sometimes be negative, so we're taking away 2 each time and so on. So it's negative 2n, and then it's plus 10. Please put corrections in if you need to. If you struggled and you didn't use the table, that might be why. So in the previous lessons we used the table, so maybe go back and have another look at those. Brilliant. Right, again. Oh, that's annoying. There we go. Recap number 2. So find the nth term of the following sequences. So we did look at fractions last lesson. So remember, you're looking for an nth term for the numerator at the top and the denominators at the bottom. If you feel quite confident, you can pause the video and have a go. If not, I'll just go through this first one with you. So just ignore the denominators for now. We'll look at the numerators, which are 1, 3, 5 and 7. And remember, just always assume, if I put it here, that n equals 1, then 2, then 3, and so on, unless you're told otherwise. Okay, so we've got n as 1 here. We'll just pop that in, just so we remember. So we'll find the common difference first here, and it's plus 2. It's plus 2 every time. So we know we start off with a 2n. Okay, so we're starting off with 2n here. Now if n is 1, 2 times 1 is 2, but we want 1. So I have to take away 1, and it works every time. When n is 2 here, okay, 2 times 2 is 4, but we want 3, so we take away 1. Brilliant. So that's our numerator. So denominator here, look, you can see, again, we're adding 2 each time. So it's 2n. Now if n is 1, 2 times 1 is 2, and 2 times 2 is 4, and so on. So that works, and we get our answer. Right, either you're going through the answer all together, in which case I'll go through in a moment, or you can pause the video at this point and have a go at the other questions, okay? Good, here are answers. So 4n plus 5 and 5n plus 6, 3n at the top, and then 5n plus 2, and then n and n plus 1. So remember, n on its own just means that number, okay? So our success criteria today is to recall how to apply and find the nth term rule. We've done that, hopefully really successfully. Silver is to recognise special sequences. Some of them we have touched upon before, so it won't all be brand new. And then gold is to be able to continue special sequences. So can you add the next terms? Can you find other things about them? And can you problem solve? Okay, so what we already know, I'd like you to copy this down. So we've done a lot of work on arithmetic sequence, and they have a common difference or a constant. It's plus or subtract an integer. So we can see here that the constant is just adding 3, and here it's subtracting 2. So if it's adding or subtracting the same value each time to get from one term to the next, it's arithmetic. And then we've also looked at the Fibonacci sequence, where you add the previous 2 terms together to make the next term. Okay, so we can see here that if we add the 1 and the 1 together, we get the 2. If we then add the 1 and the 2 together, we get the 3, and the 2 and the 3 together, and we get the 5. Okay, if you can copy these down, pause the video as you do this, that'll be brilliant. Lovely. Okay, next thing, we're going to have a slightly closer look at Fibonacci. It's quite important. Some of the rules to do with it help us out later on. So we've started the Fibonacci sequence here. What I would like you to do first is just work out the first 12 terms of the Fibonacci sequence. So you've got 1, 2, 3, 4. You've got the first 5. Can you work out the next 7 and then write that sequence? And then just a thinking task and explain why the Fibonacci sequence always has a repeated pattern look of 2 odd numbers followed by an even. 2 odd numbers, and then this one, if we've done the first task, is even. Why is that? Okay, please pause the video as you complete these 2 tasks. Okay, good, brilliant. So Fibonacci sequence, they should be our first 12 terms, which you should have no problems. And then this bit's quite important. Now, with regards to the Fibonacci sequence, this is what comes into play. Okay, so when you add 2 odd numbers together, you always get an even number, and that works here. 2 odd numbers gets an even, 2 odd numbers gets an even, and you see that as it goes along here. If you add an odd and an even, you get an odd, which is why there's always an odd number after your even number that you've used, and then the other patterns here. What I would like you to do is copy this down for me, because it's going to come into play quite a lot today, but so is this one here where we look at this idea of multiplication, particularly with our next task. So please pause the video down and copy those 2 mathematical rule tables down, and these will always be the case. Thank you. Okay, good. Right, these come into play now. Okay, we're looking at prime numbers. Okay, now we know a prime number is a number that has 2 factors, one in itself, and we should know from previous lessons, previous topics when we were actually in school, what the first 10 prime numbers are. You certainly would have looked at these lower down the school. Now, an important thing to remember is there's no nth term formula for the sequence of prime numbers. You just need to know them, and I've said this to you before, so you need to practice them, look, cover, write, check, whatever it is, just learn them. Now, also important to remember, particularly when we do some problem solving in a moment, 2 is the only even prime number. Okay, every other number is odd. All of the odd numbers in the world aren't prime, but all of the other prime numbers will be odd numbers, and we can see that from here. Okay, an example of an odd number that's not prime is 9, because 9 has 3 factors, 1, 3, and 9. Because if you multiply these pairs of numbers together, you get 9. Okay, so it's important to recognise that. Right, we're going to have a look at a challenge now. Now that we have these 2 rules down here, and I've got them here again, although you should have copied them down. Let me have a look. So, P is an odd number, okay, and Q is an even number. State whether each expression is odd or even. I'm just going to go through the first couple with you. Okay, so we've got P plus 1. P is an odd number. Okay, so we've got an odd number here plus 1, which is an odd number. So if you do odd plus odd, you're always going to get an even answer. Okay, so your answer to that will be even. If we look down here, okay, P is an odd number, but we're doing P squared. Apologies, we're doing P squared. So remember, when you square a number, you times it by itself. So you're doing odd times odd. If you do odd times odd, you get odd. Okay, so what I would now like you to do is just work through and try and decide whether each expression will get you an odd or an even answer. And there are some super challenge questions here that you might choose to have a go at. Please pause the video as you do this. Right, good, so here's our answers. So we know we should have even. So Q is an even number, add 1, which is odd. So even add odd gets us odd. Then we've got odd add even. So odd add even is odd. We know that one's odd because I explained it brilliantly. And then remember that this actually means multiply by. Okay, so we're bringing 2 into play here. So we've got odd times even, which is even. Okay, and then you're doing even plus 1, which is odd. And even plus odd gets you odd. Okay, well, let's have a look here. So we've got an odd number as an even number, which we know is odd. Okay, and then we've got an odd number subtract an even number. Okay, so think very carefully about what that gets us. Okay, and it gets us even, an odd subtract even, is odd. And then here we've got even times even. Well, let's have a look. Even times even gets you even. So then you've got an even number as an even number, which gets you an even answer because 4 is even. Then we've got odd times odd, which is odd, even times even, which is even, and odd add even gets you odd. And then here, remember when it's cubed, it's p times p times p. So we're doing odd times odd, which gets you odd. Okay, so those two together get you odd. So then you're doing odd times p, which is an odd number, so we should get odd. Okay, these are unusual sorts of questions, but you do get these questions quite a lot, particularly in any of your examinations in year 11. They always crop up, and it's about understanding these links here, but we use them quite a lot today. We're going to use them again when we look at prime numbers, incorporate that as well. Okay, so just take your time over them. Again, if you still haven't written this down, please write it down. Okay, right, next we're going to incorporate this idea of prime numbers now into these mathematical rules. So just a reminder here of what the prime numbers are, and then that 2 is the only even prime number. So now we've got three things happening. We've got p is prime, q is odd, and r is even. And we're going to say if each of these expressions is always odd, always even, or could be odd or even, okay? Now this is a bit trickier because it incorporates prime. So prime number isn't always odd because it could be 2. So you've got to work it out carefully. So here we're doing prime number, that's what p stands for, times an odd number. Now prime number could be 2, which is even, or any other number which is odd. So we know that if we do odd times odd, we get odd. But if we do odd times even, we get even. And we can check that here. So if we pick 2 as our prime number, so 2 times an odd number, so an even times an odd number is an even answer. Okay, and then pick an odd prime number, so 3, okay, and 3 times 5 is 15, which means it could be odd or even. So our answer is X because that's either. Okay, then we've got a prime number plus an odd number plus an even number. So again, we need to repeat this idea of if the prime number was 2 or if it was any other odd number that's prime, okay? And you do both of those tasks. So we do it with a 2 first, so 2 plus an odd number plus an even number, and we get 11, which is odd. And then we're going to use those two numbers the same, because these rules are the same, but we're just going to use an odd prime number instead, and always go with 3 because it's the smallest. And this time we get an even number. So our answer could be odd or even. Right, then here we've got prime times odd times even. So remember, work it out as if you're using 2 as the only even prime number and then 3 as an odd prime number. And again, just stick to 5 and 4, keep it easy. So 2 times 5 is 10, times 4 is 40, which is even. That makes sense because we know that even times odd gets you an even number, which will be 10. And even times even gets you even. And we can see that from here. And then we've got odd times odd, which we know gets you odd, which is 15. And 15 times 4, which is odd times even. Odd times even gets you an even answer. Okay? And then the last one, we're squaring. So we're not using prime numbers this time. This time it's just an odd number squared and an even number squared. So let's just go 5 squared times 4 squared. Well, 5 squared is 25. Plus 4 squared. And then 4 squared is 16, and we know 25 plus 16 is 41. Is that always the case? Well, it depends, but here, look, we've got odd plus even, and we know that odd plus even gets you odd, and it always gets you odd, so it's an O. Please take your time over these. You have to think about it really, really carefully, and you may need to look at these examples more than once, and that's not a problem, okay? You might want to copy these examples down, pause the video. Otherwise, can you please have a go at these questions? So remember, P is prime, Q is even. When you're working with prime, always work it out as if you're using 2, as if you're using 2 as your only even prime number and an odd prime number, okay? So try it with both of those types of integers, okay? And that will help you out. Right, please pause the video as you answer these questions. Right, good. So for the first one, we should have odd or even, because we know if we choose our prime number as 2, 2 add 1 is even add odd, and even add odd gets us odd. And then if we use 3 as our prime number, 3 add 1, so odd add odd gets you even. So it could be odd or even. Then here we should have odd or even, and then we're doing p squared, so prime squared, again odd or even, because your prime number could be 2, and 2 times 2 we know equals 4. That's our only even number, so then we just test it with an odd number, so an odd prime number, and look, we get an odd number, so it could be either. Then we've got prime times even plus 1, and you should get just odd. And here you're adding together a prime number and even number. Remember, try it with 2 and then try it with 3 and see what happens for both, and you should get odd or even. And then we've got 2 lots of prime, so try it with 2 lots of 2, and then also try it with 2 lots of 3, and then you get 4, and then you get 6, and then 3 lots of an even number, or 3 lots of 2 will just be 6, and 3 lots of 2 would be 6. So you'd always get even because you get 10 and 12. Just take your time over it. Look, it's quite clear this is a complex task, but it's certainly achievable by all of you, and that's why I'm having to do lots of writing with my fabulous tablet, because it's really hard to show it just through animations. Okay, you have to write things down and think about it carefully. Okay. Right, next thing, geometric progression. Now, this blue box here is important, and again, we've looked at geometric progression already. I'd like you to copy down the blue box for me. Just a reminder, geometric progression means you multiply or divide to get from one term to the next by the same value. So you're multiplying or dividing by a constant. So we can see here in the examples, it's just timesing by 3. You times the previous term by 3, to get to the next term, but then we can see here we're dividing by 2, look, there we go, and that's geometric. So some students go, well, is it not arithmetic because it's a constant? Arithmetic is adding and subtracting, geometric is multiplying or dividing, so just look out for that, because you could be asked what sort of sequence is this. Okay, so we're going to have a look here. Well, what are the geometric progressions taking place? Well, we're timesing by 2 and then times by 3, then we're dividing by 2 and dividing by 3. Can you please now have a look at these sequences, write them down, and then identify the term-to-term geometric progression rule to get from one term to the next. Please pause the video as you do this. Brilliant. So you should have times by 3, times by 5, divide by 2, and divide by 3. And please feel free to have your calculator in front of you and be using it. I might not have mentioned it at the start, but it wasn't necessarily necessary then, but we'll use our calculators from this point onwards if we need them. Okay, so just have it ready with you. Right, good. But now we're going to have a closer look, because we can see here it's geometric. Of course it is, because look, we're timesing by 2 each time. But if we are knowledgeable mathematicians, we will notice something about these numbers. And this number sequence is actually powers of 2, okay? And that just means that if you did 2 to the power of 1, oops, easy, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on, you'd get that sequence as your answers. Look, 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, and 2 to the power of 4 is 16, and 2 to the power of 5 will be 32. So that sequence is actually powers of 2. Okay, so the nth term is actually 2n. Okay, so for this sequence, the nth term is 2 to the power of n. Remember, n is 1, 2, 3, 4, and 5. That's the same, and that doesn't change unless you're specifically told. And we can look at it in a table that we're used to seeing. So here's our n values, and the nth term is 2 to the power of n. Well, just input the 1, the 2, the 3, the 4, and the 5, and you get your sequence. And look, now if you're asked what is the term-to-term rule for this sequence, you could say times by 2. But if you're asked what's the nth term, it's not times by 2, it's 2 to the power of n, and that's quite important to remember. Now, could you work out the 10th term in the sequence? Well, you could do, because this time we're just being told, well, n is going to be 10 this time, so we just change that there to a 10. And if you do it in your calculator, 2 to the power of 10, you should get 1024. Lovely. Right, have a go at this now. So you're going to work out the first 5 terms of these sequences. This time at the nth term is 3 to the power of n and 6 to the power of n. Please use your calculator and then have a go at the B question, and please pause the video as you do this. Right, brilliant. So we should know, again, we're looking at n being 1, 2, 3, 4, and 5. So in your calculator, you put 3 to the power of 1, get an answer, 3 to the power of 2, 3 to the power of 3, and you should get these answers. And again, you'll notice that the term-to-term rule, we're just times in by 3. But really, what it is, it's 3 to the power of n, because 3 to the power of 1 gets you 3, 3 to the power of 2, so 3 squared gets you 9, 3 to the power of 3, 3 times 3 times 3 gets you 27, and so on. And then this one here, okay, you should get 6, 36, and so on. And again, you'll notice the position to term rule looks like times by 6, and it is. If you asked what the term to term rule is, it's times by 6. But actually, what you've done is you've just inputted these into your calculator, and so on, up to 5, okay? Then it says work out the 8th term of the sequence with an nth term of 4n. So if you're trying to find the 8th term, it just means n is 8. So this doesn't change just because the things we're looking at are a little bit more complicated. N is always the term number. And you get 65,536. If anyone did that without a calculator, email me, let me know. Brilliant. Right, please now have a go at these problems here. Work out the first 5 terms of the sequences with the nth term as shown, and then work out the stated term for the series with the nth term as shown. So that shouldn't be 12 to the power of n, it's 12n, so 12 times n, just be aware of that. And please pause the video as you work through these answers. And then once you've done them in your calculator, 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, and put your answers, notice what the term to term rule looks like and how it links back to this value here. Brilliant. Please pause the video as you have a go at these questions. Right, look, so you should have these answers to 3ai, then 3aii, you should have these, and these, and you'll notice that the position to term rule here is just times 4, times 7, times 5, times 9, and times 8, which links perfectly here. So if you ever get a sequence where you look at it and you go, it's asking me for the nth term rule, but it just looks like I'm multiplying 4 each time. 4 to the power of n. Oh, look here, I'm timesing by 7 each time. I don't know what the nth term rule is. You do. You're timesing by 7 each time, so it's 7 to the power of n. Right here, so what you're doing here is you're just doing 12 times n, and n is 5, so you get 60. And here, you're just doing 2 times n is 20, so you get 40. Some nice simple questions for you there. Right, we're going to have an even closer look here. So now that you know this sequence we've just worked through in our teach problem earlier has an nth term of 2 to the power of n, can you then work out what the nth terms are for these sequences below? Well, if I bring this down here and I write 2, 4, 8, 16, 32, okay, we can see here that this is very similar to this, except each of these numbers in the sequence below are just 1 less. So we know the nth term for this is 2n. But 2n, if n is 1, 2 times n, oh sorry, not 2n, let's get rid of that mess. Let's get pointer options, eraser, apologies, and then let's get pointer options, bring the pen back up. We know we're doing that, okay? So we know that if n is 1, that means 2 to the power of 1, which is 2, but we have a 1 here. So to get from 2 to 1, you have to subtract 1. If we have here n as being 2, you're doing 2 to the power of 2, which is 2 times 2, which is 4. We don't have 4, we have 3. So each time, all you've got to do is you do 2n, and then you subtract 1. Well, you'll notice here, look, there's our powers of 2 sequence. And again, I'm happy to write it again here. So notice how much I love this contraption. I can't wait for you to see it. Right, that's our powers of 2. So we know our sequence includes 2n, which gets us 2. So 2 to the power of 1 is 2, but we want 3. So we add 1. 2 to the power of 2 is 4, but we want 5. So we add 1. There we go. And then this one here, you might initially look at it and go, oh, well, it's 2n plus 4, because 2n gets you the 2 here, then you add 4 to get 6. But adding 4 doesn't then work each time. 4 add 4 is not 12. So sometimes you have to look at it carefully. And actually, if you do 2 to the power of n, so n is 1, 2 to the power of 1 is 2, times by 3 gets you 6. 2 to the power of 2, 2 times 2 is 4, times by 3 gets you 12. So you can write it like that. Or you can write it the other way around, 3 times 2 to the power of n. Okay? Right, still using this powers of 2. So all of your nth terms are going to start with 2 to the power of n. But then you need to work out how you get from that to here. And it might help you to make sure you've got this written down above. So it almost looks like a table that we've used before. Please pause the video as you work out the nth term rules here. Lovely. So we should have 2n subtract 2, because if n is 1, 2 to the power of 1 is 2, but we want 0, so we take away 2 and that works each time. Then we've got 2 to the power of n plus 2, because again if n is 1, 2 to the power of 1 is 2, plus 2 gets you 4, 2 to the power of 2 is 4, plus 2 gets you 6, 2 to the power of 3 is 8, plus 2 gets you 10. Okay, and then it's 2 to the power of n times 2, because everything is doubled what it is there. Okay, lovely. Right, now we're going to look at a close look at square numbers. So again, we should be familiar with them. And how we get our square numbers is by just squaring each individual number. So 1 squared is 1 times 1, 2 squared is 2 times 2, 3 squared is 3 times 3, and so on. Okay, so the first 6 terms of our square number sequence are 1, 4, 9, 16, 25 and 36. And that one there, it's not clearly on it here, but that's just made by doing 6 squared, and that gets us 36. So the nth term is just n squared, because whatever n is, we've squared it. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And if we follow that nth term rule, what will the next 3 terms in the sequence be? Well, the next thing you do is 7 squared, which is 7 times 7, which is 49. Then you do 8 squared, okay, which is 8 times 8, which I'm hoping you know is 64. And then it will be 9 squared, which is 9 times 9, which is 81. Okay, now we actually refer to these as quadratic sequences. Think about quad, this idea of squaring something. Remember, quad means square, okay? But how do you know it's a quadratic sequence? How do you know you've got a quadratic sequence? Because it might not always look exactly like this, and you've got to be really, really careful. And it's the constant appears in the second difference. And there we go, look, need an eye. Anyone spotted that? Well done. It's really important that we understand what that means. So normally with an arithmetic or a geometric progression, you would have a constant difference. But here we can see, well, we're adding 3, then we're adding 5, then we're adding 7, and then we're adding 9. So you're looking at that and you're thinking, well, it's not arithmetic because I'm not adding or subtracting the same value, and I'm not multiplying or dividing by anything. So the reason you know it's quadratic is we look at the difference between our difference. And actually, look, that second difference is constant. And that's how you know it is quadratic, okay? And you might choose to actually copy this down, okay? Something to refer back to. And what I would like you to now do, and it's quite a challenge, so really think about it. Given the nth term, give the nth term of each of these sequences. They're all related to square numbers, so you know all of these sequences will start with n squared. Okay? But we know n squared gets us these numbers here, but we want those numbers there. So after doing n squared, how do we get from here to here? Okay? Please pause the video as you have a good go at this. Good. You should have, for the first one, n squared plus 1, because again, remember, we know that n squared is these numbers. But we don't want those numbers, we want these ones, and they're all plus 1, okay? So again here, n squared times 2, again, because if we've got these are our square numbers, how do we get from there to there? We're going to multiply everything by 2, and you could have the 2 and the n squared the other way around. Doesn't matter. 2 times n squared, not a problem. And then we should have n squared minus 1. Really well done. Make sure you stay with me. Right, now, quadratic sequences. What I would like you to have a go at, and this is actually an easier part of it, is when you're given the nth term rule, can you work out the first 5 terms? And you might choose to use a bit of a table. So I've done the first one here for you, where n is 1, 2, 3, 4 and 5, and we're going to do the n squared part first. So remember, that's when you times n by itself, okay, so n times m. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on, and then we add 5, and therefore that is our sequence. So tables are really, really good. We've used them quite a lot during this chapter, and you can still use them now. If you've chosen not to so far and you've been successful, keep doing what you're doing. Please pause the video as you work through these problems. Right, good. So we should then have -2, 1, 6, 13 and 22. Remember 3n squared actually means 3 times n squared, and it's important you do that bit first. Okay, BIDMAS. So 3, 12, 27, 48, 75, and then 19, 16, 11, 4, -5. You might have chosen to do -n squared plus 20. You'd still get the same answers in the end. Okay, lovely. Right, please can you now have a go at these 3 questions? So we haven't explicitly looked at something like C in this lesson, but we have in previous lessons. So please pause the video and work through these practice examination questions for me. Right, good. So our first 5 terms should be 3, 6, 11, 18, 27. So the 10th term would just be 10 squared, because that n becomes a 10, plus 2, 10 times 10, is 100, and 100 plus 2 gets us our 102, and then a term in the sequence is 402. Which number term is this? So is it the 10th term, the 20th term, the 30th term? How do we find out? So the first thing we do is we write it like a linear equation, okay? And we use linear equations a lot in, I think it was chapter 15. And remember I said to you, these things crop up all the time, so it's important we know them. So we want to just know what n is. So we've got to get rid of this plus 2 and then this squared issue. We'll get rid of the plus 2 first. And you get rid of plus 2 by subtracting 2 from both sides to keep it balanced. So then you're left with n squared equals 400. Now, what is the inverse of squaring? Well, it's square rooting. Okay, so you're looking for that symbol, this symbol here, on your calculator, and you just have to type in the square root of 400, so you get n equals 20. So sometimes you're asked, when do you hit a 402 in the sequence? That's a big number. You don't want to be writing out all of those values all the way up to the 20th. You might get it wrong. So this is a quick way of doing it. So it's the 20th term. Lovely. Right, cube numbers, a close look. So think about square numbers, what we talked about, that second difference being the same, squared 2. Now looking at cube numbers. Now you should know that cube means to multiply a value by itself 3 times. So that means 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so on. Okay, so they are our first 5 cube numbers. So the nth term is n cubed, which should now make sense. If you think of 1, 2, 3, 4 and 5 being n, if we cube them, that's the sequence we get. How would you calculate the next 3 terms? Well, you'd have to do 6 cubed, you'd have to do 7 cubed, and you'd have to do 8 cubed. And the answers to those would be the next numbers in the sequence. Right, but again, so I've popped back. How do you know that that's a cubic sequence? How would you know that's the case? Now remember, with a square, the square numbers, the quadratic sequence, the second difference is the same. So let's just have a look here at our sequence, and you don't have to write all of this down. It's just, I find it super interesting. You know, I find everything interesting. Let's just get that out of the way. So if we look here first, we've got plus 7, plus 19, and then we've got plus 37, and then we've got 125 minus 64, which is plus 61. Okay, so it's not arithmetic, it's not geometric, it's not the same thing happening. What's the second difference? What's the difference between 7 and 19? Well, it's plus 12. Okay, then we think, well, what's the difference between 37 and 19? And it's 18. And then we think, well, what's the difference between 37 and 61? Well, it's 24. So it's not quadratic because the second difference isn't the same. Hang on a minute. This is exciting. Plus 6. That third tier of difference is the same. Okay, now what you could get is questions that say, what sort of sequence is this? And if you don't remember that as the cube numbers, that's another thing you do. You can find, right, the first difference isn't the same. Is the second? No. Is the third? Yes, it's cubic. It's a cubic sequence. Brilliant, okay? And even if you had an nth term of n to the power of 3 plus 7, you would still get that third tier of differences that has a constant change in value of plus or minus something, okay? But using this basic nth term rule of n to the power of 3, where n is our term number, please can you find the 10th term, the 15th term and the 28th term, and please do use your calculator. Please pause the video as you do this. Brilliant, so we should have 1,000 because that just means 10 times 10 times 10. Then 15 cubed is 3,375, and then 28 cubed is 21,952. Brilliant. Right, last thing, okay, this probably is taking more than one lesson, that's fine. Now, we recognise these, we've seen triangular numbers a lot, so that's our position term number, and this is our sequence, so 1, 3, 6, 10, 15, and this is the nth term. You do not have to remember this, okay, at this point, so don't worry. You do need to remember this. You do need to remember that the sequence of triangular numbers is these values, where you're adding 2, then you're adding 3, then you're adding 4, then you're adding 5, okay? So you're recognising what's happening there each time, okay? You're going up in one value at a time. So next would be 21, then it'd be 28, okay? Now, what I would like us to look at is, well, if we didn't want to, if we were asked to find a big next number, a big like the 30th term or the 40th term, we don't want to write all these values out as a sequence. Is there a quick way of doing it? And there is, but it relies on you remembering this. But again, you don't have to. You can just add the values on each time. So let's find the 6th term. We know what that should be already because it should be add 6. So we know it should be, the answer we get to at the end should be 21. Oh, apologies, it should be 21. Okay, so we'll just substitute in 6 for n. So we know that 6 plus 1 is 5, and half times anything is equivalent to, and I've said this to my groups 1,000 times, dividing that value there by 2. Okay, so we end up with 3 times 7, and then lo and behold, we do get 21. Right, what I would like you to do is find the following terms in the triangular numbers sequence, and you may choose to use this, or you may just choose to keep working along where you add 2, then you add 3, then you add 4, then you add 5, then you add 6, and keep going as long as you remember it's the 1st, 2nd, 3rd, 4th, 5th, 6th term, then keep going. Okay, please work out the 8th term, the 16th term and the 20th term, and please pause the video as you do this. Good, you should have 36, 136 and 210. Now, just to ramble on a little bit more, this idea of quadratic sequences, cubic sequences where it's cube numbers and triangular, what you really need to be doing at foundation is be able to recognise that's what the sequence are. So if you were given this sequence of numbers here, and you might have a multiple choice question that would say, is this triangular numbers, square numbers, linear sequence, or geometric progression, you would need to be able to look at those numbers and go, that's triangular numbers. So it's identifying what that type of sequence is called. Okay, it's really important that you can do that. So here's what you have to do. You've got 3 tasks. You can do them before the second PowerPoint or after, it's not a problem, but these 3 all link to this first PowerPoint, and they're all to do with recognising sequences. And Thor did say, I have much to learn, and I know that. So work through carefully. Hopefully you've got something out of the PowerPoint. Look back at things again if you need to. And even Thor had to work really, really hard at special sequences, but he got there in the end, and just look how pleased he is about it. Really well done, team. You'll hear me later.